Welcome everyone to part 5 of the hexadecimal notation lesson. In this part we're going to be looking at the reasons why we use, as computer scientists, this notation called hexadecimal. So starting off with the first point, it is a shorter way of representing data, right? So the information that you see on your screen as a programmer would be much more condensed. It would be much more shorter. So for example, if we have a binary number on the screen, which is 01010101, I know this is quite easy to memorize, but imagine you have thousands and thousands of bytes that you have to look at. It does get a little bit confusing, and you will lose track of where the data is and what it is you're actually looking at. So if you saw the same data represented with 2 digits like this, 55, it would be easier for you to memorize this and also communicate it to other users in your team as well. So using hexadecimal notation is a shorter way of representing data, and the information on your screen is condensed. It is much more denser. Okay, and on that point, we can see here that any number between 0 and 255 would only require 2 digits in hexadecimal notation, but it would require 8 digits in binary. For example, if you wanted to represent 255 in binary, you would have to write 8 ones, like so. But in hexadecimal notation, you would only need to write FF. So 255 could be represented simply by FF. And if we look at this graphic here, it shows us at which point do we need to add another digit to the notation to represent larger numbers. So we can see with binary here, we would have to add another digit at number 2. We would have to add another digit at number 4, another digit at number 8. So what that means is, to represent the number 2 in binary, we would have to add a second digit to the number. To represent number 4, we would have to add a third digit, like so. To represent the number 8, we would have to add a fourth digit, like so. So we are not even up to number 10 yet, and in binary we have to write 4 digits like that. In decimal numbers though, we only add a second digit once we get to the value 10, as we can see right here. So any number between 0 and 9, you would only need 1 digit, 0 to 9. But to represent the number 10, you would then have to add a second digit like this. So this is in decimal, don't get confused, this is in binary. I know these two numbers look the same, but their values are quite different. And in decimal numbers, once you get to the number 100, you can then add a third digit, and then again at 1000, you would add another digit like so, and so on and so forth. Now looking at hex numbers, we can see that you would add an extra digit to the numbers once you are at 16. So this number in hex would mean 16. And the next time you add a third digit is when you are at 256. So anything up to 255 in hexadecimal notation only requires 2 digits. And 256 would be the one that adds the third digit to it. Okay, so it is clear here that you can represent more with less using hexadecimal notation. All right. Now, because hexadecimal numbers and binary numbers map so well, it's easier to edit data in your computer, because all you would need to do is change 1 hexadecimal digit, and that would change 4 binary digits in turn. So if you have, for example, a number like let's say 5, 5, in hexadecimal notation, and I changed this 5 to 5A, so I changed it to an A, I have changed the binary representation of it to 01010, whereas before it was 0101. So instead of changing 4 binary numbers, I simply changed 1 digit in hex, and that in turn changed the entire 4 bits of binary numbers in the computer. It is the easiest method to convert to binary than from decimal notation. So converting decimal numbers to binary is much more harder than converting hexadecimal numbers to binary as well. Because it maps so well, it's much more efficient to use it to edit data in a computer. So for example, if I wanted to change again these binary numbers, 0101 to 1010, instead of changing the 5 to a 10, having to write 2 digits like this, I can use hexadecimal notation and I can change it to just 1 digit, and that would map very well onto binary. Now it's also important for us to understand that computers do not work with hexadecimal numbers. This notation, this number system that we're talking about, is only beneficial to the human being to be able to understand what the computer is doing and to be able to edit what the computer is doing much more efficiently. The computer works with binary, and that's it. It is only beneficial to the human being, to the user of the computer, to use this number system. And that also brings us to this next point, that all the data in the computer is still stored as binary, so using hexadecimal notation doesn't mean that you're using less space in the computer. It only means that you are able to see much more information with less data on the screen. It is easier for you to edit that data by changing less amount of symbols, and it's easier to convert to binary from hex than it is to binary from decimal numbers. Alright, these are the benefits of using hexadecimal notation in computer science.